Good evening, everyone. We are starting class now. So in the previous class, we have discussed about the variable and some data type that we have discussed. So today we are going to move ahead and we are going to understand the variable. So now over here you can see there is two type of variable that you are able to see it over here. One is local variable and then after that there is global variable. So you can see over here, when we talk about the constant and the variable, what are the major difference over there? So the local variable, those are inside the function or the block, which is called local variable. And when we talk about global variable, those are outside of all the function on the top or that can be in the bottom also. So that is outside from any function, that is called global variable. So I'm just going to share with you one example over here. So this one is a local variable that you can see it over here. So now over there you can see this one is void setup. There is nothing inside the void setup. And in the void loop, there is two variable int x, y, both are integer type. And int z, that is the third one variable. And you can see over here, these are the local variable. So what is the meaning of that local variable? I'm just going to make you understood with one example of Indian politics. So just take an example of Prime Minister of the India. So when we talk about any other countries and when we talk about who is the Prime Minister of the country in India, who is the Prime Minister of the India, so the people know about it that Narendra Modi is the Prime Minister of the India. So when we talk about who is the chief minister of West Bengal in European country, might be they don't know about it. When we talk about the mayor of Chandigarh, might be they don't know about it because the prime minister is representing a global variable over here because that is known everywhere. But when we talk about the local variable, just take an example of prime minister of sorry that chief minister of West Bengal. So every citizen of West Bengal know about the chief minister of West Bengal. Might be they don't know about the mayor of Chandigarh, but they know about the chief minister of West Bengal. In the same way, when we talk about the Maharashtra and other states, so their local leaders are being known in the local area. When we talk about the global leaders, those are familiar in the local region also as well as in the global region also. So in the same way, when we talk about the local variable, like this one is a local variable, this one is valid inside of void loop. When we are going to call x outside of this void loop, it will show error over there. So this one is local variable, and when we talk about the global variable example, so you can see these are the global variable. These are defined above on the top. That is int t and s. Two variable, then float c, that is constant. Constant means that initial value 0. These are the global variable declarations. Then when we are going to call that variable again like t and s anywhere in this void setup and that loop, that will work. One example that I'm just sharing over here so that you can understand it, the local variable and global variable. So now we are going to talk about the local variable and global variable. So first of all, just take an example of simple variable that we are going to discuss over here. So start new circuit. So over there, we are going to take Arduino and we are going to write program and we are going to understand those variable type. So go to the programming and now we are going to talk about C++ coding. Continue. And now this one is simple code over there for LED on off. So I'm going to delete this code and I'm going to write a simple code over here for local variable and global variable. Now I'm going to make first of all global variable declarations. So you can take like integer a comma b. Two variable we have taken it. Separately also you can define then integer a, then integer b. Like this also you can define. These are the global variable definition. Now what is the meaning of that? So what I'm going to do, if I have to use the global variable a, so I can write a is equal to, sorry, that should be in a capital, a is equal to analog read. Analog read, r should be the capital. And then what we can do over there, we can use over here any pin, analog pin A0. So this one is whatever value we are going to store over here from analog pin, that can be stored in the variable A. Now we no need to declare it again and again, because we have declared it on the top. It is a global variable. No need to declare it again. So, or we can use over here, sorry, this one we have done in a setup. So over here A is equal to, okay, that is not an issue. You can read it over here, and same I'm going to use it over here in the void loop. Analog read A0. So in replacement of A, you can make it over here A1, and you can do over here B. So these two variable I have used in void setup and void function. Mean now no need to declare it again and again. So when we are going to start simulation, code will work over there, and there is no error over there in the code, because we have declared those variable on the top. These are known as a global variable. Once we have defined global variable, no need to declare again and again. Once only we have to declare it. So when we talk about the local variable, so now we are going to talk about the local variable. So you can see I'm going to delete those two variables. So now you can see I'm going to use over here int a. So int a, or you can define directly over here int a. A is a integer type, data type. So in the a we can store only the value, those are integer. So now if I'm going to use over here a is equal to analog read a1, so it will show error, because now this integer a can be used further in the void setup only, because we have used local variable. We have defined it local variable. Now you can verify it. This a show error over there. Now it is saying that this one is not declared. So whatever variable we are using in the C++ code, we have to declare it. Either that should be a global variable, or that should be a local variable. So that we have to declare it. That is the ultimate purpose over here, to show you that what is the meaning of local variable and global variable. So this one is analog read A1, and this one is integer A. And again, if we are going to use A over here, we have to declare it over here integer. Then only it will work fine. So these are the local variable, and earlier we have discussed variable outside of void setup and void loop at the top over here. Those are global variable. That is the meaning of local and global variable. So we can use further those local and global variable later on. So first of all, we are going to understand those variable, what is local variable and what is global variable in the programming. So we are understanding today about the programming concept in the C++, that how we have to program it and how we are going to use those programming concept later on. So now you can see over here, these are the local variable, and we have discussed over there global variable also. So over here we are having global variable also. So now when we talk about operators, so what are the operators? Operators mean logic operators, like less than equal to, greater than equal to. So there are different operators that we can use it for different uses. So now over here we are going to talk about operators. Logic operators. So first one is arithmetic operators, and then comparison operators, then compound operators. So that also we can use it. So when we talk about arithmetic operators, so am I audible to all the participants? Voice is audible. Kindly give your response in the chat box via typing Y and N. Am I audible to all? Voice is clear to everyone? Okay, that's great. Thank you so much. Whenever you are face any difficulty while listening, you can type in the chat box. Okay, now we are going to talk about operators like arithmetic operators, comparison operators, boolean operator. These operator we can use in different language also. C language and other language like we are using Python and all that. So operators work similarly, but there will be a small difference of representation of those operators in the different programming language. So if you are familiar with the Python, then also you will able to use those operators. And if you are familiar with the Python, you will able to use C++ easily, because basic functionality, basic conditions we are going to use same over there. Just only the representation and the syntax of the writing the code will be little bit different. Now over here, we are going to understand the operators. What are the different operators? So first of all, you can see arithmetic, mathematical operators that we are going to discuss, like plus, minus, multiply, divide, and modulo. So what is the meaning of that, that you can understand? So first one is assignment operator. When we talk about equal, it's not a equal, it's a assignment operator. It shows that A is equal to B, that is known as a assignment operator. So what is the meaning of this? So one example I'm just giving you over here. A first A value is over here. I'm taking it 5, and B value is equal to 6. So now if we are going to write A is equal to B, now A value you are going to check it out, that value will be 6. That value is 6, because A we have assigned, that is equal to B. B value is 6. So now A is equal to 6. This one is A equal to B. It's not like that A and B both are equal. So that is the assignment. Whenever we have to write equal, so double equal we have to use for comparison, that A is equal to B. For that, what we are going to do, we are going to use 2 equal in C++. So 2 equal we have to use it for comparing the value. A is equal to B. This one is comparison over there, that we are going to use it. So now this one is additions. Add two operators, A plus B, it gave you like whatever value of A and B. So we can sum it. This one is a summation, adding operator, addition. Subtraction like this, A minus B, that you can make it like this. Like if A is 20 and B is 30, so you can make it 20 into 10, 30 minus 10 like this. Then multiplication, you can multiply A and B like this. So I'm just revising this value of A and B. So over here, what has taken A and B value. So if we are going to do A plus B, that is 20 and 10, 30. B, okay. A is 10, B is 20. So A is 10, A plus B, 20 and 10, 30, A minus B. So that is 10 minus 20, so minus 10. A into B, 20 into 10, 200. B by A, that is 2. B modulo A will give you 0. This one is the reminder. So you can see A and B both are not equal. Now when we are going to make A equal to 2, it means A value is over here. A equal to B, that is 20. Okay, so now you can see over here subtractions, division. This one is a division like this. This one is a modulo, that is very important. Modulus operators and the remainder of after an integer division. It means when we are going to divide B by A, what will be the remainder? That is known as a modulo. So when we are going to divide B, 20 divided by 10, so then we are getting it like 20 divided by 10, 2, and again that 2 we are going to divide it over here. So what we are going to get it reminder, that will be 0. So now, so these are the operators that we have used over there. That is arithmetic operator. So that we can use it in the program. So these are some more commands over there. So now the things that we have discussed: arithmetical operators, comparison operator. When we talk about what are the comparison operators, so let me discuss over here. So when we talk about the comparison operator, that is double equal to, that is the comparison operators, or what other can be, that can be greater than equal to, that is the comparison operator, or that can be less than equal to, that is the comparison operator. So whenever we have to compare any sensor value, we are going to use that comparison operators. Then the boolean operators. So the boolean that is being used over there, get greater than, less than, and all those booleans operator is being used over there. Then after that, bitwise operator, then after that, bit byte binary operator that is being used. Those are for advanced applications, so that we are not going to use it right now. So then after that, so these operators, we can use it over here, boolean operator like and, or, that also we can use it over here. Then bitwise operators, 6-bit, 9-bit, 8-bit, and all that. Then compound operators and all that. So commonly we are going to use 2 to 3 operators over there in the programs. So now we are going to move ahead with some more programming concept that we are going to see over here in this program. You can, so these are the global variable. So these are known as a global variable. Then after that, you can see void setup, and this integer we have used over here. This one is a local variable, and this one is also local variable. So these are global variable. Just like 8-bit, 16-bit, bitwise operator when we talk about it. So over there you can see 8-bit mean how much value we can store it over here in the operator. Byte, character, and all that. 16-bit, more value we can store it over there in the cup that you can see it. 32-bit and more than this one, you can store value over there. Like these are long and long, float, int, unsigned int, by here. So now we are going to talk about some important concept, that is analog and digital. So whenever we have to read any value in the Arduino, so over there we can read analog signal or digital signal. Earlier we have used the digital signal to read in the Arduino. Now we are going to read any kind of analog signal. And then after that, how we can write analog signal, that is also important. So analog read, analog write, both condition we are going to use it over here. Analog read, analog write, that we are going to discuss over there. So for that, what we have to do, we have to use over here analog read. So whenever we are going to use analog read over there, so whenever we are going to use analog read over here, so how it will work, that we are going to discuss first. First we are going to discuss analog read like this. So we have to read like potentiometer or any other, we have to read it in analog read format. So how we can write code over there, this one is the code for reading analog data. So how we can read analog data, that we are going to discuss over here like this. So whenever we have to read any kind of analog sensor, we have to use over here ADC. ADC is being used in the analog pin like this. Over there is a ADC. ADC stand for analog to digital converter. So when we are talking about ADC over here in the Arduino, ADC stand over here, analog to digital converter. So in the ADC, what we are going to do over here, we are going to read value in the Arduino, that is 0 to 5 volt. So 0 to 5 volt we are going to read in the Arduino. So that value will be get magnified. So that value will be get magnified in the Arduino in the format of 0 to 1023. 10 ADC with the 10-bit ADC, that we can call it 2 raised to power 10-bit ADC in the Arduino software, Arduino program or the hardware over there. So this 10-bit ADC mean that is 0 to 1023. So whenever we are going to read value 0 to 5 volt on the analog pin, it will magnify this value in the scale of 0 to 1023. So how it will work, that we are going to see in the program. So first of all, we are going to read any analog signal using this potentiometer, and we can use breadboard also. How breadboard is working? In the breadboard, these lines, these points are connected internally, and these columns are connected like this. These columns are connected internally like this. So that is the breadboard working. So you can use breadboard also in your circuit for making a prototype. So how to write code, that we are going to discuss. Let's see the code. So now I'm coming to the code part, that how you can read any analog signal. First of all, we are going to use potentiometer to check it out how it is working. This one is my potentiometer. And over there you can see, first of all, we are going to check this potentiometer only. So there is 3 terminal. So first terminal we have to connect with the ground in the Arduino. So this one is a black color, you can take it black. And then after that, this one is second one, and this one is third one, that you can take it. Second and third. So the second we are going to take it wiper, and third one is output. So third one we have to connect with 5 volt. And then first one we are going to connect it over here with analog input in the Arduino. So this one is the signal one, you can make it orange color, and this 5 volt you can make it red color. So these are the connection of this potentiometer. We can read it like this. But first of all, rather than reading in the Arduino, we are going to read output in the multimeter. So we are going to use multimeter over here, and to check it out how this multimeter will work. So over there, what I'm going to do, I'm going to connect it like this. Like this. Okay, so now over here, we are going to see that how output we are going to get it. So this one is negative, and this one is positive output. Start simulation, and you will be able to see 0 volt. So when we are going to rotate this potentiometer, our voltage will be changed from 0 to 5 volt. 0 to 5 volt. 0, and wherever we are going to put it, so value will be accordingly. Like in the middle, so there will be 2.5 volt. So it means we are reading analog voltage. So we are converting this voltage 0 to 5 volt we are taking from the Arduino, and we are converting it into an analog signal. 0 to 5 volt, that is a variable signal that we are going to get it over there. So now what next we have to do over there? We are going to read this value in the Arduino. 0 to 5 volt value, we are going to read it in the Arduino. So let's see how that will work, that we are going to discuss it. So now I'm going to connect a signal wire of this center wire, that is the signal wire in the potentiometer. This one I'm going to connect it with the A0 pin. This one is orange color wire, signal wire. So whatever we are printing it on this multimeter, same value we are reading in Arduino A0 pin. Now we have to write code for reading any kind of analog signal. So first of all, we are going to take one variable, that is int You can take global variable or local variable also. I will let you know the difference between both of them again. So int voltage. So one variable I have taken it, that is int, integer type and voltage. Then over there I'm going to use pin mode. For serial begin you can use it, serial dot begin to start serial programming. Serial programming mean you can send data, you can print data to the serial monitor. For that you have to start serial library. Serial dot begin, and we are going to use over there 9600, that is the baud rate. Serial dot begin. Then after that, what we are going to do over here, we are going to use over here that reading the value of voltage. So directly we have to write voltage is equal to analog read, and pin we are using it over here A0 pin. So this one is simple code for reading a sensor value from A0 pin. And then we have to print this value on the serial monitor. So we are going to use serial dot print, and we are going to use over here, that is the voltage. That is the voltage. So we are printing whatever value we are storing over here in this variable. This variable we are storing data type, that is integer. Only the integer value we can store it, and that value we are printing it over here, and we have to use semicolon at the end. Now let's see what is coming. You can use some delay also, delay of 100 millisecond I'm taking it. This one in a millisecond, as I told you in previous class. So this one is in a millisecond. Then you can start simulation. So when we are going to start simulation, it's saying that some error is over there in the code. What is error? You can see error in analog read. So that we have written. So analog read R should be a capital. Now it will work fine. Let me check it out. So now there is no error over there in the circuit. So we are reading 5 volts. So you can see in the serial monitor, we are not able to identify the value. So what we have to do, in serial print, we are going to write two words over there. Two alphabet. One is LN. LN. LN stand for new line. So over here we are going to use LN. LN representing over here, that is new line. Serial dot print new line, that we are going to use it over here. Then after that we are going to start seeing out what output we are getting it on the serial monitor. Now you can see value coming in a new line 1023. So as I told you earlier in the over here, that whenever we are going to read value, so that value we are going to read in the format of 10-bit. In analog read, whatever value we are reading it, that is we are reading it in a 10-bit format. 10-bit means the value is 0 to 1023, that we have discussed earlier also over there. So over there we have discussed that when we are reading value 0 to 5 volt in the Arduino, so we are going to read that value in the Arduino 0 to 1023. When we are giving 5 volt to the Arduino, Arduino will read in the format of 1023. It is being at magnified value. So because there is inbuilt ADC over there in the Arduino, that's why that value is being at magnified over there like this, in that way. Then after that, this one we are going to check it out in the code. If we are changing value, so how the value is changing over there. So now we are changing this value. You can see voltage over here, and in the same way the value is changing. Like value is 2.5, so this one is the half of 1023, that you can see it. And again, as we are changing it, so it is being like this. So when we are changing 0 to 5 volt, the value being magnified in the Arduino, and Arduino will read in this format. Again, if you want to see value in this format 0 to 5 volt, so you have to do one calculations over here, and you have to convert this value into the voltage. So I'm going to take one integer over there, or float. You can take it float. Float mean in the float variable, what you can store? You can store value in a point, in a decimal. So float, I'm taking over here. Value is equal to, so we are reading value over here, voltage. So you can convert this value, voltage, and we are going to multiply it. You can multiply it 5 and you can divide it 1023. So you can write in 5.0 because we are using float over here, and 1.23.0 like this. So this value will be in a float, and you can use semicolon. So this value get converted again in the format of 5 volt. This one is the formula that we have used. How the formula is working, that you can see it over here when we talk about the formula. So how it will work? So you can see in a very simple example. In 5 volt or in 1023 value, we are getting 1023 value when reading in the Arduino. It means we are providing 5 volt to the Arduino. So one value is 1, what we are getting it 5 divided by 1023. One value is x, so x is multiplied over there, x like this. So this one is the formula, we made it over here. So this one is a 2 over here. 2, no need to get confused. So now over there you can see that we have converted this value into again 0 to 5 volt. Let me print this value again. So we have to print value over there on the serial monitor. Whenever we have to print value on the serial monitor, we have to write it like this, serial dot print, and then after that we are going to use over here the value. This one value we are printing it over here. This one value we are printing it over here, and you can use semicolon over there with the value. So now you can use ln also, new line ln, and over here there is already ln. So let me check it out what value we are reading it. So this one is the value we are reading earlier. Now this one is a voltage 2.4, that you can see it. Because both value we are printing it, you can comment this value if you want to read only the voltage value. So now after the conversion, we are reading same voltage, whatever voltage we are giving to the Arduino. You can see it like this, 3.3, same voltage we are getting it, 4.5, 5.0, like this. So we are changing it, same voltage Arduino is reading, because we have converted their magnification again back to the input voltage. So that conversion we can do it if we want exact same voltage that we are giving it to the Arduino. Because there is inbuilt ADC, analog to digital converter. That's why that value is being converted like this. So this one is simple. We can use it over here. That is like we are reading value and we are writing code over there. So this one is simple code for reading analog value or voltage reading that we have done over there. So that code you can save it also over there. That is analog read voltage. So these are the integer, we have taken it voltage. So again, whenever we are using voltage, no need to define it again. Now further we are going to move ahead with analog read. So some project we are going to make it based on this analog read. So what project we can make it using analog read? So that we are going to discuss over here. So for that, I'm going to use this analog read, and based on that, what I want to do, I want to make on and off any motor or anything based on the sensor value, this value of voltage. So I'm going to write one condition over here, if conditions. So how to use if condition over here? So without conversion, directly I'm using if condition over here. Without conversion, I'm going to use if condition on this value. This value is 0 to 1023. And this one value we are printing it on the serial monitor. So how to write if condition? You can use if, then bracket. You can start bracket like this and then curly braces and start it and you can enter it. So in this curly braces, you have to write your if condition. So over there you can use like whatever condition like voltage is greater than equal to any value, you can take it like 450. If the voltage is greater than equal to 450, that what you want to execute. You want to write like LED on off you want to do, motor on off you want to do. So you can use over here digital write. You can use over here digital write, and the pin number we can use it any pin for writing. You can make it high and low. And one more important point, whenever we are going to use any digital pin over here, high and low, we have to define that pin in a void setup also. Otherwise, that pin will not work properly. So we have to use over here, that is pin mode, and pin we have to define it, pin mode, and over there pin we have to define it. So we are going to use over here, that is pin number 12 as a output. As a output like this. So pin mode 12 number pin as a output like this. And then after that you are going to see this one, and over there you can use else condition also. This one is if condition, you can use else. In else you have to use curly braces and you can close that curly braces and you can write same code. 12 number pin high, you can make it 12 number pin low. So this one is code like we have done earlier in the graphical coding. Now we have done using C++. So you have to practice little bit in the C++ also, so that you can more comfortable in a C++ code also. When you have to make any complex program, that also you can make it using C programming. So now over there, this one is the code that we have used for LED on or motor on and motor off on 12 number pin. Now we have to use one motor also over there. So let me use any motor. This one is the motor that we are going to connect it over there on the 12 number pin. One is ground and this one is 12 number pin that we have to connect it. Then you can start simulation and you can check it out on the serial monitor, that what we are getting it. So the value of the serial monitor is 1023. In the 1023, what is happening over there, you can see the conditions. If the value is greater than 450, motor will be on, otherwise motor will be off on the 12 number pin. So we are going to reduce the value. If the value is less than 450, still the motor is on. Value is still motor is on. When value is less than 450, on the 450 also motor is on. When value is less than 450, you can see motor will be get off. This one is the logic that we made over there. This one is the program that we made over here for running the motor and turning it off based on sensor value. So this one is potentiometer we are using right now. In replacement of this potentiometer, we can use any kind of analog sensor also. So any kind of analog sensor we can use it over here. So I will use this analog sensor after this. So this one project is for just understanding the code. Now in replacement of this one, I'm going to use temperature sensor. So whenever we have to read the temperature, based on the temperature, if we have to turn on fire alarm or we have to turn on any pump, so that also we can do it over here using this one. So how we can interface this one project can we get saved, but I'm going to modify this one project. So the code will be same. What I'm going to do it, I'm going to use over here one temperature sensor. So you can scroll down, you are going to find one sensor. This one is a temperature sensor. So what are the pin over there in the temperature sensor that you can see it? One is power, second is V out, and third is ground. So the ground pin you have to connect with the ground terminal like this. And then after that, this V out and power. So power we have to connect with the power. Power means that you can connect it with 5 volt. like this. And then this one is V out. So V out can be get connected over here with A0 pin, analog pin. So this one is V output pin. So you can do the color coding. This one is black color, and this one is black color, ground is black, and power is red color like this. So this one is temperature sensor, we are reading it, and whenever we are using temperature sensor, some modification we have to do in the code. Directly it will not provide a value like this, so you can check it out also. So we are changing temperature, so we have to use some conversion factor over there. So maximum value it is providing, that is 358. So we have to read this value in the format of temperature. So for that you can see simple code over here for the temperature sensor. So directly I'm going back to the text block format so that you can see temperature block how it will work. So I'm going to delete over here. I'm going to write code for temperature sensor from the graphical, and then I will convert it in a C++ so that you can understand it. So over here I'm going to use input, and I'm going to use directly analog read temperature sensor block. We want to print it, go to the output, and you can take variable also over here. This one is a variable, create variable. So I'm going to take one variable with the name of temp, and okay. So this one is variable that is being created, temperature. So you can define this temperature in the start. Set temperature initially you can set it 0, and then over here we are going to get output. Read temperature pin, okay. Set temperature to 0, initial value we have set up it. Okay, now what we are going to do, we are going to output and print to serial monitor. But before that, we want to store this temperature value over here uh, in this variable. So you can use over here this variable, set temperature value like this. So whatever temperature value is over there, we can read it in this variable. That value is being get stored. Now you can use print to serial monitor. So this value you want to print it, now the value is stored in the temperature. You can go to the variable and you can take this one only. So the value, whatever value stored in this variable, that will be printed on the serial monitor. You can check it out. Start simulation, and you can see the value is coming 24. That is also 24 over here. So same value we are changing it over here, same we are getting it over here like this. Now you can see the code over there. So you go to the book block plus text, stop simulation, block plus text. So this one is code for temperature. So we are using variable, temperature is initially 0. This one is a global variable that you can see it. We have taken variable temperature. So this one is a global variable. Initial value is 0. And then after that you can use temperature, and this one is the conversion rate. Whatever value we are reading from the analog, so this one is the multiplication factor of the sensor. That value we can get it from the data sheet. So from the data sheet of this temperature sensor, we can get that value, that conversion factor, that we have to use it. That is multiplication and subtraction factor. And then this value we are printing it on the serial monitor. Now you can go to the text only, so that we can modify this code. So this one is temperature code, this one is the conversion factor of the sensor. Now we can use condition over there. So any condition we want to use it, like if conditions on the sensor value, if temperature variable value is, if you have to use bracket over there, temperature sensor value is greater than equal to 60 degree. And then what should be over there? If the temperature value is more than 60, we are assuming that there is a fire incident. So we can make condition over here. So you can use over here one bracket, curly braces, start it, close it, and we can write over here condition that pump we want to make it. So you can use over here digital, write like this, and you can use over here pin number. Pin number we are using 12 number pin for turning this motor on. You can make it 12 number pin high and make it high, semicolon. In else conditions, what you want to do, you have to use else conditions. If the temperature value is less than this, value is less than, if the temperature value is less than this, so what you want to do, you want to make this motor off, less than 60 degree. So we can make it low. So the temperature value is low over there. You can check it out. So now what we are doing over there, we are going to check it out simulations, and you can see on the serial monitor also temperature value is 24. We made a condition for more than 60. When the temperature will be more than 60, then only you are going to see over here that this one will be turned on, like this. Motor will be turned on now. You can see it on 12 number pin. But there is one mistake. What is that mistake? The RPM of motor is very small, very less. Why it is so? Because in the code we are using 12 number pin high and low, but this 12 number pin is not defined in the void setup. So whenever we have to use any pin as input and output, we have to define it. That is pin mode, and 12 number pin in the setup we have to define it. 12 number pin, that is output, like this. So now after doing this, what we are going to do, we are going to start simulation, and you are going to see motor RPM will be full. When the value is more than 60 degree, temperature is more than 60, you can see 5555 RPM is there. When the value is less than this, then the value is over there, you can see it. Like this. So now, based on that, you can make your condition and you can make your project easily. Like if you want to make automatic fire alarm, that also you make based on the temperature sensor, and you can use different sensors over there. It's not only limited that you have to use like temperature sensor, any kind of analog sensor you can use it, and you can use this code. And the syntax you have to use it analog read for reading any kind of analog sensor. This one is the conversion factor of the sensor that will be different for different sensors. So that you have to practice it. So if you are going to do practice, you will get understood that which sensor we have to use it, what is the meaning of that. So today we have used one temperature sensor and we have used one potentiometer. So two projects we made today. So you have to practice it and you have to make those projects in your classroom. Classroom means you have to make it on the Tinkercad. Automatically that project will be get displayed in the classroom. No need to worry about it. So two projects you have to make it for analog read using potentiometer, analog read using temperature sensor. So this one you can take a photo of there. This one is the conversion factor of analog read. This one is conversion factor over there that you can see it. Now you can see more clearly this temperature conversion factor. You can get it from the data sheet also. TMP sensor name is TMP. And when we are going to search TMP, so you will get it over here, TMP temperature sensor. When we call about TMP temperature sensor, so TMP 36 or something like that. So their data sheet you can see it. And in the data sheet you are going to find that conversion factor. So what should be the conversion over there? These are the TMP sensors. This one is TMP, we are using it. That means 3 size. So in this temperature sensor, What is the conversion factor that you can find it over here when we are going to scroll down? That is the detail about it. How much value it can read it over here. Scaling factor minus 25, yes. So this one it is saying that scaling factor TMP 35, 10 degrees Celsius to 125 degrees Celsius, 10 millivolt per degree Celsius. Mean in 1 millivolt it can read 1 degree Celsius. So a 10 millivolt, sorry, in 10 millivolt it will read 1 degree Celsius. That is the conversion factor. So that is the conversion factor that with the help of that we can make the formula over there. So let me check it out if there is any formula for that. There is no dedicated formula. So that formula we have to make it our own. Temperature sensor, ground connections over there. 1 millivolt per degree Fahrenheit. So they used over here one formula of conversion of this one via output, but we have used the sensor directly. They have used one op amp or something like that. So there is more circuit, so no need to get confused about it. Simply we have to use that conversion factor that we have seen over there. So today we are going to sum up this session over here, and we have discussed analog input concept. In tomorrow class we are going to discuss about analog output, how we can control motor speed or any appliance speed control, light intensity control, analog output signal that we are going to give it from the Arduino. So how it will work, that we are going to discuss in the next class, and their programming also, how we have to write program for analog output. So if there is any doubt, any queries, you can type your queries in the chat box. And if there is no queries, you can type N in the chat box. So if there is any doubt, any kind of queries, you can type in the chat box, and otherwise you can type N in the chat box if everything is clear to everyone. Okay, thank you so much. So we are going to sum up this session over here. Thank you so much.